Let's talk about the invisible glue that holds pretty much everything together, chemical bonds. And forget just memorizing the terms. By the end of this, you're going to actually see the fundamental difference between the two big ones, ionic and covalent.
I mean, really, stop and think about that for a second. One is a hard little crystal you can hold in your hand. The other is a liquid. What on earth makes them so different? Well, it all boils down to a simple choice their atoms make. Do we give something away or do we share? That's the whole secret, and we're about to make it super clear. You know, we've all been there in chemistry class, right? You jot it down, you memorize it for the test. Ionic bonds transfer electrons. Covalent bonds share them. Got it. But then the question comes, well, why does that make salt act the way it does? Suddenly, that simple definition doesn't quite cut it. So let's build a real picture in our minds.
Okay, to really nail this down, let's forget about chemistry for just a minute. Let's use a simple analogy that has everything to do with this core idea. Imagine you and a friend are just trying to get your finances in order.
So, in the first scenario, let's say you've got an extra 10 rupee note just kind of sitting there. Meanwhile, your friend needs exactly 10 rupees to feel stable. So what do? You just give it to them. It's a complete transfer. Now you're both stable and happy, and because of that little transaction, a bond, a connection, forms between you.
And that, right there, is the heart and soul of an ionic bond. It's not a negotiation, it's a complete handover. One atom gives an electron away, another one takes it. This makes one atom positive and the other negative. And just like tiny magnets, they're now powerfully attracted to each other. Boom.
Okay, now for scenario 2. This time, you and your friend both have 5 rupees, and you both need 10 to be stable. Nobody's in a position to just give money away. So what's the solution? You pool your resources. You put the money together in the middle, and now you both have access to the full 10 rupees. You're sharing to make it work.
And yup, you guessed it, that is a covalent bond in a nutshell. Instead of a transfer, two atoms decide to share their electrons. They form a partnership, a team, where both of them get to use those shared electrons to become stable. It's all about cooperation.
All right, analogy time is over. Let's apply this to something you definitely know, table salt, or as chemists call it, sodium chloride. This is our classic giver scenario playing out in the real world. So here's what's happening at the atomic level. A sodium atom has this one single extra electron that it's just dying to get rid of. And over here, you have chlorine, which is just one electron short of being perfectly stable. It's a match made in heaven. Sodium completely gives its electron to chlorine. Now sodium is a positive ion, chlorine is a negative ion, and that opposite attraction makes them snap together. That's your ionic bond.
Now let's look at our sharer example in action. Good old water, H2O.
The situation here is totally different. An oxygen atom needs 2 more electrons to be stable. But it's not going to find another atom that's just willing to hand over 2 of them. But it does find 2 hydrogen atoms, and each one has an electron it's willing to share. So oxygen makes a deal. It forms a partnership, sharing electrons with each of those 2 hydrogens. Now everybody gets to use the electrons they need, and they form a stable water molecule through covalent bonds.
So the analogy is fantastic for getting the concept. But what if you want a fast, reliable way to predict what kind of bond will form between any 2 atoms? Well, there's kind of a chemistry cheat code for that, and it's called electronegativity.
Don't let the big word scare you. Electronegativity is just a fancy term for an atom's electron greed. That's it. It's a measure of how badly an atom wants to pull electrons towards itself. Some atoms are super greedy, others not so much. And it's the difference in their greed that tells us everything we need to know.
And this table here gives us a really simple rule. You just find the greed value for each atom and subtract to find the difference. If that difference is huge, greater than 1.7, it means one atom is so greedy it just rips the electron away from the other. That's an ionic bond. If the difference is smaller, they end up sharing. And if that sharing is a little bit unequal, we call that a polar covalent bond.
And what do you know? The rule works perfectly for our 2 examples. The difference between sodium and chlorine is a whopping 2.1, clearly ionic. For water, the difference between oxygen and hydrogen is 1.4, which falls right into that unequal sharing or polar covalent zone. The numbers confirm our story.
Okay, so who cares, right? Why does any of this matter? Well, because knowing the bond type is kind of like having a superpower. It lets you predict how a chemical is going to look, feel, and act in the real world without even seeing it. Think about the consequences. Because ionic compounds like salt are locked into this super tight grid of positive and negative charges, they form hard crystals. It takes a ton of heat to break them apart, so they have high melting points. And they can only conduct electricity when you dissolve them in water, which lets those charges finally move around. But covalent compounds like water, they're just individual, neutral molecules, kind of hanging out. That means lower melting and boiling points, and they don't conduct electricity. The bond really does determine everything. And that brings us right back to where we started. The reason salt and water are so wildly different, the reason one is a hard crystal and the other is a liquid, it all comes down to that one fundamental choice, made at an impossibly small level, to give or to share.
So let's put this all together one last time. We'll do a quick side-by-side recap, just to make sure this all really sticks with you.
And here it is, the whole story in one shot. On the ionic side, you've got a complete transfer of electrons. This creates charged ions, like in salt, which can conduct electricity when dissolved. On the covalent side, it's a cooperative sharing. This creates neutral molecules, like in water, that don't conduct. It's that simple. Giver versus sharer. So remember, that tiny, invisible connection is everything. Now that you can actually see the difference between a giver and a sharer, what else around you starts to make a little more sense? Why is sugar, which is also a crystal, so different from salt? And why is diamond, which is just carbon atoms sharing electrons, one of the hardest things on Earth? Once you understand the bond, you can start to understand the world.